Hello everyone, welcome back to my workbench up here in my study at Dongit's Model Railway. I am continuing my search for DCC decoders with acceptable ABC behaviour which are in stock and available to be purchased. Here I have an ESU LokPilot 5 for evaluation. For a proper fair test, I'm going to try it out in the same loco I used for my previous ABC review. This is a Hellion Class 25, which I'm using for this because it's a brand new modern specification locomotive and will provide a fair test platform. First I need to remove the previous chip I tried out. The ABC implementation in that one was so awful there's literally nothing I can use it for. I know it's fashionable to cut bad DCC chips in half with side cutters for giggles at the moment, but there is an outside possibility there's an unpowered cab car out there with a 21-pin socket in it. Function-only decoders are surprisingly expensive, and I'm sure this chip would do fine in that application. Let's have a closer look at the ESU LokPilot I'm about to install. This is the cheapest version, the LokPilot 5 Basic. I have the 21-pin version, product number 59029. All the information on the box is in German, but even if that's foreign to you, numbers and acronyms come through loud and clear. It does confirm it has ABC, something that wasn't necessarily true of the basic SKU in previous LokPilot versions. There is a comprehensive manual available in English, but it is not SKU specific. It may describe some features which are not available on the basic SKU. Unlike any DCC decoder I've had previously, the motor settings were not automatically reasonable. I've never previously had to tune motor settings just to get a loco to run properly. Not with Zimo, not with Trainomatic, and not even with that DCC Concepts decoder. But this, by default, it was oscillating so badly the loco would literally derail itself. I didn't film the process of getting to acceptable motor settings as honestly there was a lot of trial and error and not a lot of obvious procedure. But with it close enough, let's see what this decoder can do under ABC braking. ESU support two different configurations of ABC. With one in CV253, it will wait until it needs to brake and then brake to a stand. This is the same behaviour that Zimo implement. I've set it up to stop here when entering at a full-scale speed of 90 miles per hour. At half speed, it's stopping significantly shorter. It could be failing to compensate properly for mechanical momentum and overrunning the desired stopping point at full speed. It may also be slow to react to ABC and be starting to brake later than expected. At 1/4 speed, it's stopping a bit shorter again. With 0 in CV253, it will brake at a lower rate if entering the section at a lower speed. The full speed entry is still running to the same location. But now the half and quarter speed options are stopping at the same point. This definitely sounds more like failing to compensate for momentum properly than a slow reaction time, as lower rates stop at the same location despite having a different entry speed. There doesn't appear to be any way to compensate for mechanical momentum in the ESU chip, unlike with the Zimo chip. This loco has plenty of weight and two decent sized flywheels, so I went searching through my roster for locos which I'd successfully set up with low momentum compensation settings, and I decided a Bachmann 411 might make a better candidate. I put the chip in a spare power car I had to hand. At half speed, it stopped here. At a quarter speed, it stopped a bit further up. I don't know why a quarter speed took longer to stop than half, but maybe I hadn't got the speed table properly sorted out when I shot this. At a full scale 90 mile an hour, it went a bit further still. It definitely looks more worth tuning it properly for this loco than with the Class 25 though. Now moved into my real set, and with a little more polish on the speed settings, a full speed stop looks rather sharp, but it is stopping reliably in the expected distance. At half speed, it does stop a bit shorter. Unless I rebuild both my layout and the club layout to have longer braking sections, or configure this train to always run less than scale speed, I'm not going to be able to do better than this with this chip. At a quarter speed, it stops in the same place it did at half speed. To give a comparison point for this, here's what the 25 I started working with can do with the Zimo chip I pulled out of the SEP. I've done nothing with this chip other than configure the basic speed parameters to give a scale 90 miles per hour at full speed and 45 miles per hour at half speed, and set the stopping distance to an appropriate distance, in this case 13. I'm not using the momentum compensation feature at all yet, that's still set to 0. At 25% speed, it stops here. At 100% speed, it's all of 1 to 2 centimeters further along when it stops, and the stop looks visually very smooth, much smoother than the ESU. In conclusion, I'm disappointed in this ESU decoder. It's making a fair effort at constant distance ABC braking, but it's clearly not up to the standard I'm used to from the Zimo chips. I will leave it in this SEP unit for now, but I'm not planning to buy any more of these chips. The Zimo is clearly a cut above what the ESU can do, even before using the feature to reduce braking distance when entering at high speed to compensate for mechanical overrun. I clearly just need to figure out where I can buy Zimo decoders at the moment, as no one in the UK has had any in stock, and hasn't for most of the year. See you next time, up here in the study at Donget's Model Railway.